It may be 5 million years away, but human Y chromosomes are disappearing entirely. Females still have 2 normal X chromosomes, but the Y chromosome is rapidly deteriorating, leaving males with only 1 X and 1 withered, weak Y chromosome. But what does that mean for us? Joining us now is Darren Griffin, a professor of genetics at the University of Kent in England. Professor, thanks for being here.
No problem, my pleasure.
So does this mean that we should be putting men on the endangered list?
Well, this is a question I get asked an awful lot, and the answer is absolutely not. This is currently the way in which we determine our sex, but having males and females is pretty hardwired in all sorts of species, and no, males are not going away.
But what you just said, this is currently how we determine our sex. I think a lot of people at home who don't have a working knowledge of genetics would say, well, how else do you do it? Isn't that a defining aspect of the difference between men and women? Is this a big deal? And what does it actually mean?
Well, what it means is that basically our chromosomes, if you think about the DNA in our cells, our chromosomes are basically what happens when that DNA coils up. So I've got a little prop here. Right in front of the Houses of Parliament, an old telephone wire, and all that happens is they coil up like so, they get shorter and fatter, and that's what we mean by chromosomes. So what tends to happen is that most of our chromosomes occur in pairs, a little bit like that. So that's most chromosomes in most species, animals and plants. But the weird thing that seems to happen in our sex chromosomes is that when one of them acquires a gene to make us male, so let's say this one just gets a little bit of a gene on it, that's a real advantage to doing that because it keeps our sex ratio about 50-50. Other species like frogs, for instance, determine their sex by temperature, and they get skews in sex ratio. So we hardwire that. But the downside to doing that is that when that happens, normally these chromosomes, they protect each other. They've got a little bit of a mutually support mechanism going on. So when one gets damaged, the other one can repair it, and vice versa. But if one of them's got a little bit of a sex-determining region on it, that repair mechanism around that, where that occurs, doesn't work quite the same. And that means that one of those chromosomes can get a little bit damaged, like so. Now, when that happens, it differentiates them a little bit. When they're more damaged, it means the repair mechanisms don't work quite so well. So it can break a little bit more. And it goes round and round in circles such that it gets smaller, and it gets smaller, and it gets smaller again, and maybe even smaller again, such that we get to the situation that we have now with our nice, big, normal-sized looking X and our tiny little Y. Now, that can happen either way around. So in mammals, it's a shriveled little Y in males and a normal-size X, but in birds, it's the other way around. It's the females that have the little shriveled one, and the males that have 2 normal-looking ones.
So, Professor, what does this mean? Take me into the future, 5 million years in the future. How are we going to determine, how is our species going to determine who is male and who is female?
Well, we don't know is a short answer. All we can do is look at other species. So, for instance, there are some species of rodents, spiny rats in Japan, and mole voles. And what they've done is they've simply just translocated the sex-determining mechanisms onto a different chromosome. And what that probably means in maybe another 150 million years' time, the whole process will start to begin again. So we're not overly worried. I think we've got an awful lot of things to worry about in the meantime. And it's interesting because although everybody agrees that the Y chromosome has shrunk in the way that I've just described, a lot of groups, particularly in the US, believe that that process has put the brakes on. It's stopped. Now, if that's the case, then there's nothing to worry about at all. And then even then, there's probably not a great deal to worry about anyway.
But Professor, how did you come across this discovery?
Well, an awful lot of groups, principally in Australia and in America, work on this. Basically, if you start looking at the chromosomes from all sorts of different species, we find all sorts of weird and wonderful different sex-determining mechanisms. I've mentioned temperature, sometimes it's genes, and sometimes it's chromosomes, just to name a few. So by just taking a look at every other chromosome you'll ever look at, they pretty much come in pairs, and these are the ones that don't. So where are the exceptions to the rule? So we can be pretty sure that once upon a time, the two X's were fairly normal sized. Now, this has been pretty well known since about the 1960s. We and other groups work on different aspects of this, and one of the things that myself and my colleague Peter Ellis did recently is we reviewed all the literature, and that was the reason for the new story coming out. So I think it's fair to say that the scientific world is split. Some people think that the Y chromosome will disappear completely, like it's done in these spiny rats and mole voles. Other people think that, by and large, this is the exception to the rule, and it's the Ys put the brakes on and it won't happen. So there's quite a debate going on.
Professor, I want to thank you very much for joining us. And just I'll give you one suggestion as a professor of television sciences, that one of the reasons for this shrunken Y chromosome might be that the Y chromosome was in a very cold pool. On that note, thank you very much for joining us today.
That may be the case. All right, my pleasure. Cheers. Goodbye now.